Oh yeah, that's right. Kane's about it. Okay, because I taught him the other day. All right. First of all, in your calendars, I decided on mock dates. I kind of looked at the schedule. Most everybody can do the Friday, the 18th. So I'm gonna have the Friday the 18th open, and then if you can't do Friday the 18th, then I think everybody who couldn't do that could do the 19th, and then that way we can do them back to back, and we can talk about it the following Monday. So then that way people aren't waiting a week. I think that's gonna work out best. All right. So for the time, is 10 to 1 okay with everybody?
Yeah.
Not too early, but still kind of in the morning because that's when you'll take the real thing. All right, so 10 to 1 up here. On the actual test, you are not going to be able to move on to the next session or the next section until time is up. But on this test, I'll let you move on if you want. If you want to take a break, you can take a break. But on the actual thing, like, they will make you wait. But on this one, like, if you're like, I just need to take it and then I want to leave, I don't want to like wait around, that's fine with me. But I do want you to try your hardest because that's going to help me a lot and it'll help you to kind of see where you're at. I'll have food. I'll bring lots and lots of food. If I were you, I would take breaks because it's a long test. But we'll do it that day, either Friday from 10 to 1 or Saturday from 10 to 1. Sound good? Okay. All right, we're not going to do the homework quiz because of the send-off, and we're going to just jump straight into notes. All right, so what we're learning today is about separation of variables, which went pretty well in fourth period, so I'm feeling good about it. Separation of variables is the implicit differentiation of integrals. And I know a lot of you are probably like, I don't even remember what implicit differentiation is, so let's kind of review that. Implicit differentiation is when you're taking the derivative of a function that has x and y in it. So if I wanted to differentiate this guy, because there's x's and y's over here, I'm going to use implicit. So when I take the derivative of x squared, what do you get?
2x.
2x. What's the derivative of y squared?
2y dy dx.
2y dy dx. And what's the derivative of 9? 0. And then you just get dy dx by itself. So you're going to minus the 2x, then divide by 2y. And so your derivative, dy dx, is going to be negative x over y. All right, so that was implicit. So of course we probably have a similar method for integration. So separation of variables is like implicit, but we go backwards. All right, I have the steps right here, and those are going to be like the steps as I work through the problem, so I don't need to talk about them right now, but let's fill out these blanks. When you are doing separation of variables, you are going to collect all of the y terms on the side with the dy, and all of the x terms on the side with the dx. You are only going to plus c on the x side. And I'll kind of show you the math behind it, but basically if you have a constant on one side and a constant on the other, and you subtract your constant and move it to the other side, you're still going to have a constant. So we just really need to allocate it for one side. You don't need to have it on both sides. It just makes things simpler. Now some vocabulary to check to look out for the directions. If it says find the general or particular solution, y equals f of x. If it says that y equals f of x, that means that you have to solve for y. If it just says find the general solution, if it just says find the solution, you do not have to solve for y. So just kind of make note of that. If you see this f of x here, or this y equals, make sure you actually solve for y. All right, because we're a little short on time, I'm just going to jump in and start doing some examples. What's up?
The last blank.
Oh, sorry, plus c. All right, so this is when we're gonna do the steps. So step one, multiply both sides by dx. Step one is always the same, no matter what. You're gonna move the dx to the other side. And that makes this my x side, this my y side. And it's always gonna be like that. So I wanna move all of my y's over here on the left, and I wanna keep all of my x's over here on the right. Now, when we're doing the moving part, all right, which is the part I'm on right now, to move all your terms, you can only move by multiplying or dividing. All right, you cannot add or subtract. The only thing that you can move is by multiplying or dividing. That's it. So when you think, how can I move my y's over? Your only option is multiplying or dividing. You cannot add a y or subtract a y. That will not work. All right, so how would I move my y over to the other side? Multiply it. Because then they'll cancel. So you'll get y dy equals x squared dx. Once you have all of your y's on one side, all of your x's on the other, your next step, which we were on step 3 here, is to integrate. So we are going to integrate this side, we're going to integrate this side. So what is the integral of y? Y squared over 2. What's the integral of x squared?
X cubed over 3.
X cubed over 3. And the x side is when we're going to put the plus c. Don't write this, but technically, if you plus c on the y side and then minus your c over here, it's a different c. So 2 constants added up will give you another constant. So that's why we only plus c on the one side. So you just have to plus c on the x side. And so this is your general solution. On your homework, I have 2 things boxed. I have your general solution box because I want you to check to make sure, like, did you integrate correctly? That is the first box. The second box is actually solving for y. So on this one, if I wanted to solve for y, what would you do next? Times 2. So then I would get y squared equals 2x cubed over 3. What is 2 times c? It's still a constant. I can just write it as c. You don't have to like follow along with like 2c and negative c. It's just if 2 times a constant is going to be another constant, you can just leave it as c, which makes things nice because you don't have to worry as much about the c. So you can just put plus c. All right, now y is not by itself yet. What would be your next step?
Square root.
Square root. Every time you square root, you got to do what? It's a little simple. Yeah, plus or minus. And so your solution solved for is y equals plus or minus the square root of 2x cubed over 3 plus c. And that's the second thing I have boxed on my answer key. Okay. All right, let's try another one. So go down to 24. All right, first step is always to move, to multiply by dx and move it to the other side. So that is going to be my x side. The left side is going to be my y side. So how can I move my y over to the other side? Divide by y squared. Divide by y squared. So I get 1 over y squared dy equals sine x dx. Okay, and then I'm going to integrate. Now 1 over y squared, it has an exponent that is not ln. That's regular power rule. And so how can I rewrite that so it's something that's easier to integrate?
Negative 2.
Negative 2. Alright, so So I'm going to rewrite this as y to the negative 2 dy, integral of sine x dx. All right, so when you integrate, add 1 to the exponent. So what does my new exponent become? Negative 1, and then divide by it, which is just going to make it a negative y. And what is the integral of sine x? Yes, negative cosine. And then plus c. So, yep, this is your answer. If you have to solve for y, what would you do first? Divide by negative 1, so that's going to become positive cosine x, still plus c, because it's just a constant. Constant divided by negative is still just a constant. Now this is 1 over y. And I want the y on top, right? So all you got to do is just flip your fractions. So it would be y equals 1 over cosine x plus c. Okay, let's go to 25. All right, so 25, I'm going to move the dx over. Oops, that's gone. All right, so times by dx, move it over to the other side, and then what do you have to get rid of?
Y.
The y. So we're going to divide by y, divide by y. Now this guy I'm going to leave as 1 over y, because what do I know the integral of 1 over y is?
ln.
ln, yep. So when you integrate, the integral of 1 over y is going to be ln, absolute value of y. What's the integral of x?
X squared root.
X squared over 2. And then you have your plus c. So this is your solution. Now if you wanted to solve for y, do y'all remember how to get rid of the ln? E, yes, we're going to e. And if you e that side, you're going to e this side. So the e and the ln are going to go away. So will the absolute value, which is kind of nice, because e will always be positive. So on that side, the y is going to drop down. Now on this side, I've got e to the x squared over 2 plus c. And now on the AP test, you're going to see something funny happen here with the plus c. So what they're going to do is they're going to take that plus c and they're going to multiply it in front of the e. So it'll look like this. Now I'm going to explain the math of why that works, but it's almost easier to just remember if you have a plus c in your exponent, that can come down and get multiplied in the front. All right, so the math behind that is like, it's your backwards exponent rules. So think about, for exponents, what has to happen for you to add your exponents? Like, what are your terms going to be doing if you add your exponents? Multiplying. So this is the same thing as saying e to the x squared over 2 times e to the c. Because for you to add your exponents, your bases have to be the same. So they both have to be base e. And so you can kind of split it up that way, right? Well, what is e to the c? Just a constant. And so that's why we turn it into just a c, and we multiply it and put it in the front. So that's kind of the math behind it, but it's almost easier to see if you see a plus c in your exponent, it's going to go into the front. It's not the same c, but it's still going to just be a constant that will multiply in the front. Does that make sense? Okay. So different c value, but we'll still just put it in the front. I guess I didn't need to erase all that. All right, let's look at 26. So on 26, first thing is we're going to move the dx over and multiply. All right, now remember, you only can multiply or divide for moving the y over. You cannot add or subtract. So I need to change this so I can multiply or divide something and get that y out of there. So what can I do to this expression here to help. What does it have?
GCF.
Yeah, GCF. I could take out a what?
2x.
A 2x. And when you take out a 2x, you're left with y plus 2. And now I can divide by the y plus 2 on both sides. And that way all my y's are over here and all my x's are over here. All right, so I've got 1 over y plus 2 dy equals 2x dx. So now I'm ready to integrate. What is the integral of 1 over y plus 2? What's the integral of 1 over y? Ln. So this one would just be ln y plus 2. Think about what's the derivative of y plus 2? 1. So if you made this a u sub, your du would just be dx. Like it wouldn't have anything special happening with it. So it's just ln, this is the y plus 2. And then on the other side, what is the integral of 2x?
X squared.
X squared, and then you got the plus c. Okay, so this is your solution. But now let's try solving for y. All right, so how do you get rid of an ln? You e it. So you get y plus 2 equals, what am I going to do with that plus c?
Put it in front.
Put it in the front. So it's going to be c e to the x squared. Now remember, those c's aren't the same number, but they're still both just constants. So if you see a plus c in your exponent like that, just stick it in the front. It's a different constant, but it's just a constant getting multiplied. And then what would be your last step?
Minus 2.
-2. And then some people asked a good question, do you have to actually write the -2? And the answer to that is yes, because your constant, your like plus c, is now being multiplied, so it doesn't combine with this -2. So you do actually have to write the -2 there to finish out the problem. Okay, now, technically on 27, you've done these problems before, because dy dx equals e to the x over 1 minus e to the x. There's no y there. It's just a regular integrate and go backwards. All right, so if I wanted to solve this out and get the solution, I just have to integrate e to the x over 1 minus e to the x. So you only have to really like separate the variables if it has y's and x's in your expression. Does that make sense? Now this one would be a u sub. What would your u be?
1 minus ex.
And then what would your du be?
1 over dx.
Close. What's the derivative of 1?
0.
0. What's the derivative of negative e to the x?
Negative.
Negative e to the x. All right, now, what from this du do I not want from over there?
-1.
The -1. So I'm going to move the negative over there, and I get e to the x dx. Forgot to put my dx right here. So remember with your u sub, all of this is going to just become negative du. So you get negative 1 over u du. So the 1 minus e to the x becomes u. Everything in green just becomes du with the negative in the front. And then you can integrate. What is the integral of 1 over u? ln of u plus c. And then you can plug your u back in. And this guy is in y equals, because if you think about it, what happens when you integrate dy? Like there's nothing in there, it's just an understood 1. What's the integral of 1 dy? Just y. Because it's like 1y. Does that make sense? Okay. So on this one, if I wanted to go backwards and I wanted to integrate, what's the integral of secant squared? Tangent. Plus c. So if they don't have y's and x's, they're just regular integration problems. It's when they have y's and x's, like number 30, when you have to actually separate your variables. So on this one, I've got y's and x's here. So the first thing I'm going to rewrite y prime as is dy dx. So I can actually like split the dx up and the dy up. Does that make sense? All right, so then what would I need to move?
Multiply the y.
Well,
Dx.
dx and then multiply by the y, yes. So move the dx over, then I'm going to move the y over by multiplying by y. And then you get 2x dx. And then you can integrate.
All right, teachers and students, please excuse this quick announcement. If at this time, if everybody would make their way down to the commons, down the English hallway, and into the cafeteria for a send-off for our girls basketball team. Again, would everybody make their way this way, please? Thank you.
All right, so are we okay? Does it we feel good about it?
Yeah.
Okay. The homework is only 8 questions. It's not because it's hard. I just tried to make it a little bit shorter because Monday's homework is a little longer. So I was just trying to balance it out a little bit. But we can go to the send-off. I really don't think, I think that's basically where I stopped in the other class too. I didn't really do the rest of the examples. They're kind of repetitive. What's up?
Is the answer to that why? Wait, it would be. Wait, I wrote it down.
You would times by 2
Yeah.
And then you would
times
square
the
root.
And it would be y equals the square root of 2x squared
plus c.
plus c.
Plus minus.
I will never remember plus c.
Don't say that.